OpenAI just published an official use case library for Codex with 24 documented workflows, and the majority of them have nothing to do with writing code. They range from turning Figma designs into production UI, to analyzing datasets and shipping polished reports, to building browser based games, to automating bug triage across Sentry and Slack. Today, I'm walking through every category and the most powerful use cases in each one, with the exact prompts and workflows OpenAI recommends. If you think Codex is just a code generator, this video will change your mind. Let's start with design to code, the use cases that bridge designers and developers. The headline feature is Figma to code. You paste a Figma frame link, and Codex uses the Figma MCP server to pull the full design context, tokens, variables, component variants, and assets. Then it translates everything into code that matches your repo's design system, not generic code, your components, your tokens, your spacing rules. The workflow has 4 stages. Stage 1: Codex runs get design context for the exact node. Stage 2: it downloads required assets from the Figma payload. Stage 3: it implements using repo conventions. Stage 4: it opens Playwright in a real browser, compares the output against the Figma reference screenshot, and iterates until it matches across desktop and mobile breakpoints. The second design use case is screenshot to code. Same concept, but you paste a screenshot instead of a Figma link. Codex analyzes the visual layout, maps it to your design system, and builds responsive UI. Both are intermediate level workflows that take about an hour. Next, data analysis and reports. This is where Codex stops being a developer tool and becomes an analyst tool. The workflow starts with a specific research question. For example, are houses near highways valued lower? Then Codex sets up the environment, imports raw data, profiles it, maps columns to types, flags quality issues, normalizes formatting, and runs trial joins with match rates. For modeling, it starts simple, defines targets, features, and controls explicitly. It explains leakage risks and documents limitations. And the output? You choose the format. A markdown memo for technical teams, a CSV for operations, a Word doc with proper tables and formatting for stakeholders, a PDF dashboard for executives. Codex even has dedicated skills for spreadsheets, Jupyter notebooks, and document generation. This is a complete data pipeline in natural language. There's a full Apple platform suite built for iOS, Scaffold, Build, and debug SwiftUI apps for iPhone and iPad. Built for macOS, same thing, but for Mac with sidebar detail pane and inspector layouts. Add iOS app intents, make your app's actions available to Shortcuts, Siri, and Spotlight. Adopt Liquid Glass. Migrate an existing SwiftUI app to the new iOS 26 Liquid Glass design language. Debug in iOS Simulator. Codex drives your app through Xcode Build MCP, captures evidence, and iterates on fixes. Refactor SwiftUI screens. Split oversized screens into small subviews without changing behavior. And add Mac telemetry, instrument features with Apple's Logger framework, and verify from the console. 7 Apple-specific use cases. If you're an iOS or Mac developer, Codex is now a legitimate development partner. The automation use cases are where this gets powerful for teams. Bug triage automation, Codex checks, recent alerts across Sentry, Slack threads, linear issues, GitHub issues, failing PR checks, support tickets, and logs. It synthesizes everything into a prioritized list, and you can run that sweep on a schedule. Pull request review, Codex catches regressions and potential issues before human review. It reads the dive, understands the codebase context, and flags problems humans would miss on first pass. New hire onboarding. Codex prepares onboarding trackers, team summaries, and welcome space drafts automatically. And the iterate on difficult problems. Use case turns Codex into a scored improvement loop. It keeps refining its approach, measuring results, and iterating until the solution meets your criteria. The integration layer is what makes Codex a platform, not just a tool. Slack integration. Mention at Codex in any thread, and it starts a cloud task tied to the right repo and environment. Results come back in the thread. No context switching. Create a CLI Codex can use. Build composable commands for any API, log source, export, or team script, and Codex can call them as tools. Bring your app to ChatGPT. Turn your use cases into focused apps for ChatGPT's 900 million users. And the save workflows as skills feature. Any workflow you build once becomes a reusable skill that Codex keeps on hand. You build the process once, Codex repeats it forever. The creative and knowledge use cases round out the library. Browser based games. You define a game plan and Codex builds it, tests it in a live browser, and iterates until it works. Generate slide decks. Codex manipulates PowerPoint files directly using PPTX generates images for visuals, and applies repeatable layout rules slide by slide. And learn a new concept. You give Codex dense source material, and it turns it into a clear, reviewable learning report. These aren't toys, they're productivity workflows that save hours. The codebase understanding use case deserves special attention because it's the on ramp for everything else. You tell Codex, explain how the request flows through this system area. Include which modules own what, where data is validated, and the top gotchas to watch for before making changes. End with the files I should read next. Codex traces the entire request flow, maps module ownership, identifies validation points, side effects, and state transitions. It highlights risky sections and tells you exactly which tests to run after edits. This is how you go from zero to productive in a new code base in minutes instead of days. And it's the foundation. Once Codex understands the code base, every other use case works better. Let me give you the prompting patterns that make all of this work. For data analysis, quote, I'm doing a data analysis project. Goal is your specific question. Start by reading agents.md, loading datasets, describing contents and data quality, and proposing a reproducible workflow. For code base understanding, explain how the request flows through this area. Include module ownership, data validation, and the top gotchas. End with files I should read next. For Figma to code, the starter prompt tells Codex to run, get design context, get metadata if truncated, get screenshot before coding, download assets, then implement using repo conventions. These aren't vague instructions, they're structured workflows that consistently produce high quality results. The skills system ties everything together. Every workflow on this page can be saved as a skill that Codex reuses. Your data analysis pipeline, a skill. Your bug triage sweep, a skill. Your Figma to code workflow, a skill. Once saved, Codex can execute these on demand, on schedule, or triggered from Slack. This is the flywheel. You invest time building a workflow once, and Codex compounds that investment across every future session. Combined with the Codex cloud environments, skill system, and Slack integration, you're looking at an autonomous work system, Mithil, not an assistant you have to babysit. Step back and look at the bigger picture. OpenAI published 24 use cases. 7 are Apple platform development, 4 are design and front end, 3 are data and analysis, 3 are automation and quality, 3 are integrations and workflow, 2 are creative and knowledge work, 2 are engineering fundamentals. This isn't a coding tool with some extra features bolted on. This is a platform that happens to be really good at coding. The head of Codex said it himself. What happened to engineering will happen to all knowledge work. This use case library is the proof. I've put the link to the full use case library in the description, along with every starter prompt mentioned in this video. If you're only using Codex for code, you're leaving 90% of its capability on the table. Subscribe for more deep dives on the tools that are reshaping how work gets done. See you in the next one.